Okay, I wanted to do a video on fraction review because there's been a few questions on this, and this is a common stumbling block for Math 96 students. So let's start by just talking about when you add and subtract fractions, what you need to have is a common denominator. So adding and subtracting fractions requires a common denominator. You could take some notes on this if you wanted, or just watch it. And when you have that common denominator, what you're going to do is bring your numerators together. So once you have a common denominator, you add or subtract your numerators. Okay, and just so you remember, numerators are in the top and denominator is the bottom of a fraction. Okay, and so that's adding and subtracting. You have to get a common denominator and then you bring the numerators together. When you're multiplying, you actually just multiply straight across. So multiplying fractions basically you just multiply straight across. So multiply numerators and multiply denominators. Okay, now you can, and often you want to cancel things. You can cancel, let's just say you can cancel here. And that's a useful tool when you're multiplying fractions. And I'm going to do a bunch of examples to help illustrate these two differences. Okay, so let's just take as a for instance, let's just start by doing some adding and subtracting. Okay, so if I were to add something like 3/4 plus 5/6, okay, so we know because we're adding and subtracting, we have to get a common denominator. And if I look at the denominators, I've got a 4 and I've got a 6. And what I have to figure out is what is the smallest number that these two numbers share in common as a multiple. So when I say a multiple, if I run through their multiple lists, I can say 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And this is what I'm talking about on a multiple list. 4 times 4 is 16, and so on. Okay, if I run through the multiple list for 6, 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18, and so on. Okay, so if I run through this list, then I'm looking for what is the lowest number that they share in common. And I notice a 12. Now, if you don't think about it this way, that's fine, because a lot of people, you were taught a long time ago how to deal with fractions. And so, you may just go straight to, oh, it's 12, and that's fine. But then you have to figure out, what do I multiply 4 by in order to get it up to the 12 that I need? And what do I multiply 6 by to get it up to the 12 that I need? And so I'm actually going to have to multiply the 4 by 3/3. So 4 times 3 would give me 12. Now, I have to multiply the top by 3 also, because you can't multiply by anything other than the equivalent of 1. Okay, so I'm multiplying by the equivalent of 1 here, and I have to do the same thing over here. So multiply by 2 in order to get the 6 up to 12. I would actually also need to multiply the top by 2. Okay. All right, so when I multiply, and this is now an example of multiplying fractions, I'm going to multiply straight across. So I'm going to say 3 times 3 gives me 9, and 3 times 4 gives me 12. And then here, 5 times 2 gives me 10, and 6 times 2 gives me 12. Okay. Okay, at this point, now that I have a common denominator, I can actually bring the numerators together, and I can say that this is 9 plus 10 over 12. You don't really have to do this step if you can do it in your head, but this is really what we're doing, is we're bringing the numerators together and writing it over a common denominator. Okay, so then the 9 plus the 10 would be 19 over 12. And that's an example of adding. Let's do an example of multiplying. So let's say the directions say to multiply, and let's say you have something like 3/4 times 6/9 and 5/7 and 25/14. Okay, now when you multiply fractions in the context of something like this, when you're adding and you're just multiplying straight across, and that's fine, and you can, that's how you want to do it in the context of something like this. In the context of something like this, and you're asked to multiply and you've got a big set of fractions, the easiest way to deal with this is to actually do some canceling. I could just say 3 times 6 times 5 times 14 and get my numerator, and then 4, 9, 7, 25, multiply all of that, get my denominator. But then when I get to the end here, I'm actually going to have to reduce it. And it's probably easier to it is easier to reduce it when it's actually in this form before we multiply. Okay, so when I talk about canceling, what I'm referring to is reducing. So you can go and start with whatever you see has in common. For instance, here, and you're always canceling numerators and denominators, by the way. Never a numerator with a numerator. It's always cancel a numerator with a denominator. So here I notice, I have a 3 and I've got a 9. Well, I know that 3 will go into 3 once and into 9 3 times. So what I'm doing is I'm canceling. I'm actually reducing this by a factor of 3. Now the reason that I can do that is effectively what I have, we'll finish this problem, but let me just go down here. Effectively what I have is this. I have all of these things multiplied in one fraction. I could actually rearrange this in such a way as to say, really one of the fractions I'm dealing with is 3/9. Even though it looks like a 3/4 times a 6/9, that 3/9 is there. And 3/9 is really 3 over 3 times 3, isn't it? And so you can see that this is the same thing as 3 over 3 times, you could have a 1 here, 1 over 3. This becomes a 1. This 3 over 3 is the equivalent of 1. And that's effectively what I'm doing up here is I'm saying, I've got a 3 over 3 in there. Let me take the 3 over 3 out. And what am I left with? I'm actually left with a 1/3. Okay, but this is obviously a lot of work to do it this way. We don't want to do it that way. We want to cancel. Okay, so if I continue with this process, I would say, like for instance, the 4 and the 6, I notice that 2 goes into 4 twice, and it'll go into 6 3 times. Okay, and then I notice that these 3's will cancel. So this is a 1 now, and this is a 1. And then I see that I have 5 going into 5 once and into 25 5 times. And I see that I have 7 going into 7 once and into 14 2 times. And a lot of stuff's canceling here. The 2 will cancel with this 2. Okay, and then you're taking a look at what's left. In the top, I have 1 times 1 times 1 times 1. So all I'm left with in the top is a 1. And in the bottom, I have 1 times 1 times 1 times 5. So I have a 5. So my answer here, if I were to multiply all these fractions and just reduce it instead of having to go the long way, I end up with a 1/5. Okay. Let's maybe do a subtract. That's a little. So let's just do another example here of maybe a subtraction problem. So let's say I have 7/9 minus 1/4, something like that. Okay, so again, I'm looking at my denominators, and because this is a subtraction, I'm looking at my denominators and I'm saying, what is the common denominator? I have to figure that out. And I can go through their multiple list, and you'll find if you go through their multiple list that 36 is going to be the lowest number that they share in common. And so I want to get both of these numbers to go up to 36. So I'm thinking about, the 9 here, let me multiply it by 4 over 4, because that'll get me up to 36. And the 1/4 is going to get multiplied by 9 over 9. Now, obviously, you probably see in this example that I'm just multiplying this one by that denominator and this one by that denominator, and it's not always that way. If we go back to the original example, I was multiplying by numbers other than what these denominators were to take it up to my common denominator. Okay, in this particular instance, the 9 times 4 gives us 36. That happens to be the lowest number that they share in common. Okay, so we just end up multiplying by what it looks like the other denominator, but that's not really the reason that we do it. Okay, so if I multiply straight across, 4 times 7 is 28, and in the bottom 4 times 9 is 36. Over here, 1 times 9 is 9, and 4 times 9 is 36. Now, you'll probably look at both of these fractions and see, oh, look, they can be reduced. And of course, they can be reduced because we actually just brought them up from a reduced position into an unreduced position. You don't want to go backwards and reduce them because you'll just undo what you did. We do want them to be in an unreduced form at this point so that we can actually do the subtraction because now we have a common denominator. Okay, so at this point with a common denominator, I can bring this is 28 minus 9 over 36, and if I subtract the 9 from 28, and I'm going to get a positive 19, and then that is over 36. And I take a look at this now. You always take a look at your result and ask yourself, does that reduce? And 19 over 36 doesn't reduce, so then I would be done. And that would be my answer.